Hello everyone, today we are going to look at some brief crash course on the chapter Kinetic Particle Theory. We will start with the properties of solid, liquid and gases. This is best explained in the form of a table which summarizes the main differences which are there at the level of a solid, liquid and gas. Before we proceed, we have to know that the most fundamental part that we have to understand in order to understand the whole table itself is this, the forces of attraction between the atoms. We have to know that in a solid, the forces of attraction between the atoms is strong, and in fact it is the strongest among all the states of matter. The three states of matter are solid, liquid and gas. Be it solid, liquid or gas, they are all made up of atoms or molecules. The forces of attraction between the atoms and the molecules are different. In a solid, the forces are very strong. In a liquid, the forces are weaker. But in a gas, the forces of attraction are negligible. It's as if there is no force of attraction between the particles in a gas. So let's see. Because in a solid, the forces of attraction are so strong that the atoms are held together by a strong force. The atoms are close together, the atoms are together. So, a solid will have a fixed shape. Because the atom cannot move, this means that all the atoms are glued together, they stick together. You cannot move one atom relative to the other. So the whole shape of the solid is going to be fixed. Like this one is a solid, you can't change the shape, right? So a solid shape cannot be changed. But the shape of a liquid can be changed. Therefore, a liquid has no fixed shape. For example, if you take water, you put it into a container or bead of any shape, the liquid is going to take that shape. Now, let's look at a gas. A gas, just like a liquid, has no fixed shape. A gas, you put it in any container, it's going to take the shape of that container. The next part is about the volume. A solid has a fixed volume. For example, if we take that marker, whatever the volume of the marker is, this volume is not going to change. It's going to be the same. Same is for a liquid. The volume of a liquid does not change. Okay, the shape can change, but if you take 1 liter of water, it's still going to be 1 liter of water. In whichever container you're going to place it, it's still going to be 1 liter. However, a gas has no fixed volume. If you put a gas in a small volume, you can compress a gas to make it fit into a small container, whereas you can expand a gas to make it fit into a large container. Whichever container you're going to place, this shape is changeable. It has no fixed shape. We have looked earlier at the forces of attraction. Now let's look at the way in which the atoms are arranged. Because in a solid, the forces are so strong, therefore the particles are arranged close together and they are in a regular pattern. You cannot change the pattern. Each particles are held by strong forces and they are going to remain in this way. But in a liquid, the atoms are free to move. Therefore, they will not occupy any fixed place. They're going to be around anywhere. So the particles in a liquid is disorganized. It has no fixed pattern of arrangement. If we look at a gas, the particles are more in a disorder. They can occupy any place and therefore the whole pattern of arrangement of atoms in a gas is very disordered. Next we look at the distance between the atoms in a solid. Because there is strong force of attraction, the atoms are held close together, there is little space between them. In liquid, the forces are negligible. There is still, however, some forces. Therefore, the particles between the gas is slightly further apart. But in a gas, the force of attraction between one atom and another atom is so weak that the molecules can go further apart. There's nothing that binds them together. Each atom can go away. So now they are further apart. The next part, we look at the speed at which the molecules are moving. In a solid, because the forces of attraction between the atoms are so strong, the atoms cannot move, they can only vibrate about the mean position. In a liquid, the forces are weak. Therefore, the atoms can move around to some extent throughout the liquid. But in a gas, there is no force which is holding the atoms together. The forces are negligible. Therefore, the molecules of a gas are free to move and go around anywhere within the container of the gas. Coming to the second part of this chapter, we are now going to see the relationship between motions of molecules and temperature. So, here what we want to see is, if we take a solid, liquid or a gas and we give heat energy to the solid, liquid and gas, how are the atoms and molecules of the solid, liquid and gas going to behave? Well, it depends on which state it is, but I'm going to start it from the solid state and going to show you what's going to happen right from the solid till it becomes a gas. So let's look at a solid. If you remember, the atoms between the solid are held in a fixed place because there are strong forces of attraction. So here, the atoms of the solid are held by strong forces. So the atoms of solid are held together by strong forces. When we are going to heat that solid, the heat that we give that solid is going to make the molecules move. It's going to make that, but since the molecules are not free to move, because there are strong forces of attraction between them, they will start to vibrate more and more. As we increase that heat, the molecules are going to move faster, and one thing we know, as we give heat, and there is the particles moving faster, the temperature is increasing. And this is an important relationship that you have to know, that heat equals to molecule moving faster, and when the molecules move faster, it's going to give an increase in temperature. So now we see why when we are heating a solid, the temperature is increasing, because the molecules are moving faster. Now, after heating, say that we have just reached the melting point of the solid. At this point, the heat that we give is not going to make the molecule move faster. Instead, this heat that you will give will break the force of attraction holding the atoms together. When the strong forces holding the atoms together starts to break, the atoms are going to be separated, and now they're going to be slightly further apart because there's no longer any strong forces holding the particles together. Now the solid has said to be melted and has now become a liquid. Now, the heat which you will give to the solid is not going to increase the temperature of the solid, because the heat now is not going to increase the speed of the molecule. It is only going to go to break the forces of attraction. So, if you give heat and that heat is going to make the molecule move faster, temperature is going to increase. But if you give heat and that heat is not going to make the molecule move faster, instead it is going to break the forces of attraction between the solid, then you will see the state is changing, but the temperature is not changing, but temperature remains the same, and this is what happens here. The solid is melting. Now, after the solid has melted and become a liquid, if you heat that liquid, the molecule is going to move faster. Since the molecule moves faster, the temperature will be increased. So it's just as if you're heating a liquid and seeing the temperature is rising in the liquid. Now, but let's say after heating you reach the boiling point of the liquid. If you continue heating the liquid at its boiling point, the heat which you will give in the liquid will not cause the molecule of the liquid to move faster. Instead, it is going to break the forces of attraction between the liquids. Remember, even if it is a liquid, even if the forces of attraction between the liquids are weak, but there's still a force. If you supply heat, you will break the force. When you break the forces, the atoms are now going to be completely free. They are going to become a gas. And at this step, if you heat, the temperature is not going to increase. The heat is not going to make the molecule move faster. It is only going to break the forces of attraction between the molecules and change in state. Remember, change in state, when we are heating and we are changing the state, the temperature does not increase. Now it becomes a gas. And if you take a gas, you continue to heat the gas, the molecules of the gas is going to move faster and faster, the temperature of the gas is going to increase. So that's it for the second part of the relationship between the motion of molecules and temperature. In the next part, we're going to look at pressure in gas. We have to know that a gas has the ability to exert a pressure in the container in which it is present. So if you take, for example, the wheel of a car, you fill it with a gas, that gas will cause a pressure and that will make the wheel of the car inflate. Now, how will gas exert pressure in its container? Gas molecules are not fixed, they are moving around in the container. When they move around, they are going to bounce into one another, they are going to hit each other, as well as the gas molecules are going to hit against the wall of the container. When the gas molecules are going to hit with the wall, they are going to exert a pressure. So, you have the molecules here, these are the gas molecules. It is moving and it is hitting the wall of the container. When it hits the wall of the container, it is going to exert a force on the wall of the container. The wall of the container obviously has an area. So, the force per unit area, this gives you pressure. So, this is how a gas exerts pressure on the container in which it is contained. The next part we are going to see how is the pressure that a gas exerts is going to change with temperature. As you already know, that when you increase the temperature, the molecules of the gas are going to move faster. Since they are going to move faster, they are going to collide more often. When they are going to collide more often among themselves, and they are going to collide more often with the wall of the container, they are going to cause a greater force. They are going to exert a greater force on the wall of the container. So this means that at a higher temperature, the pressure is going to increase. If we have to represent it in the form of a graph, as we increase the temperature, the pressure also is going to increase because there is more molecular collision. So temperature equals to collision and collision equals to pressure. You have to understand this. We now come to the last part of this chapter, and in the last part we're going to look at evaporation. So what's evaporation? If we take a liquid, we heat the liquid, and as we heat the liquid changes into a gas and escapes into the atmosphere. This is called evaporation. Now, why evaporation occurs? Remember that in a liquid the particles are held by a strong force of attraction. When we give heat, this heat that we give to the liquid is going to break the force of attraction between the atoms, between the molecules making the liquid. Therefore, obviously, the liquids will now have no force of attraction holding them together. They're going to go away. Consider this is a liquid. These are the forces of attraction which holds the molecules of the liquid here. When we heat, the heat is going to break the force of attraction between the molecules. So the molecules are now free to move because there's no force holding them. They are going to escape and become a gas. One important thing you have to know. When we look at a liquid, not all the molecules have the same amount of energy. Some molecules of the liquid have more energy, some molecules have less energy. When it comes the time for the molecules of the liquid to escape into the atmosphere, it will be the molecules which already have the maximum amount of energy that will escape first. So let's say we have molecules A, molecules B, and molecule C. Let's say molecule A have 10 joules of energy, molecules B have 12 joules of energy, and molecule C has like 8 joules of energy. Since molecule B has most energy, it is most energetic, when the time comes for evaporation to occur, it will not be A, it will not be C, it will be the molecules B that will escape into and become a gas. So this means that evaporation is always a process by which it is the most energetic molecules within all the molecules of the liquid that will escape into the atmosphere. Now, since evaporation will proceed, the most energetic molecules will go. What will be left? The molecules which are less energetic will be left because the most energetic has gone. But the molecules which have less energy, they have a low temperature. So this means that when molecules are evaporating, when a liquid is evaporating, it is going to lead to cooling. Evaporation leads to cooling. This is why we transpire when the temperature is hot. Because when we transpire, there is water molecules on our body. This is going to absorb heat from the body. The water molecules on our body is going to take heat from the body and escape into the environment. In so doing, when it is taking heat from the body to break its bond and escape, it's taking heat from the body. The amount of heat in the body is decreasing, so therefore we cool down. This is why evaporation is followed by cooling. In the next part, we're going to look at the factors that affects evaporation. There are three factors which affects the rate at which evaporation occurs. The first is temperature. If you increase the temperature, you will have more evaporation. This is obviously because if you are supplying more heat, it will be able to break more bonds, the molecules will have more energy and can escape. The second factor that affects the rate of evaporation is the surface area. If you have a small surface area like this, there will be a little evaporation. But whereas if you have a higher surface, a larger surface area like this one, you will have more evaporation. Now, why is this like that? Remember, evaporation occurs from the surface. If the surface is small, so there is a small amount of molecules which are in contact with the surface which can escape. But if the surface is large, you will have more molecules present on the surface that can go out. So this is why evaporation is higher when the surface area is higher. The last factor which affects the rate of evaporation is the wind speed. If the wind speed is faster, evaporation will be faster. Now, why is it like that? Consider a situation where we have a hot liquid. The molecules in the liquid have escaped and has come on the surface of the liquid like that. Now, if there is no wind, what will happen? The gas molecule, this is a liquid, will remain on top of the liquid. If it will stay here, it will prevent other molecules to escape from the liquid and become a gas. Therefore, evaporation will stop. But now, let's consider that there is a wind which is blowing. What will the wind do? It will carry away all the liquids, all the particles of the gas away. The particles will be blown away. On the surface of the liquid, there will be now the molecule. It will create space for more molecules of the liquid to escape to the surface. And this is why when you increase wind speed, there is drought, there will be more of evaporation. So that's it today for this chapter. Don't forget to subscribe to my channel to have more updates of the videos which I'm going to put in there. And till then, see you. Take care. Bye bye.